Hello! Welcome to a journey through the comparison of the effects of free diffusion versus convective mass transfer. The mechanisms of mass transfer are seen almost everywhere we look. For instance, it is the speed limit for chemical reactions, including all critical biological functions, from the uptake of nutrients during digestion to the CO2-oxygen exchange in our lungs. However, our motivation for this experiment comes from our routine decision to stir the sugar into our coffee. Following the second law of thermodynamics, we know that entropy, or disorder in the universe, will inevitably increase over time. Much like the universe, we find our coffee to taste better in its most random state, increasing the probability that each sip will be as sweet as the last. This brings us to our decision to use a spoon to stir in our sugar. If the laws of the universe are on our side, is it worth dirtying the spoon to induce the convective mass transfer in our glass? Or is the diffusion alone fast enough to reach our drink to its homogeneous equilibrium? So what's the difference? Depicted on the left, free diffusion is the movement of a solute down its concentration gradient due to the random interactions at the molecular level. This process is typically slow. While there is net movement from high concentration to low, the molecules do not have a uniform direction speeding its dispersion. On the other hand, convection is the movement of a solute with the assistance of a moving fluid, such as stirring coffee with a spoon. This process is typically a lot faster. While free diffusion is always present, this much faster mechanism of mass transfer typically overpowers the diffusion term, allowing us to assume it's negligible in some situations. Our experimental design consists of constructing an apparatus. The Mega Spinner Beta 21 Omega 240 V3 utilizes a lazy Susan bracket to allow a mounted cylinder to rotate around its central axis. The rotational motion is powered by a variable speed drill attached to a rod underneath the boards. This design will allow us to induce a fluid flow in the closed system, while keeping the geometry simple enough to make some analytical predictions about the behavior, as opposed to using a hard-to-measure stirring mechanism such as a spoon. The goal of our experiment is using a stationary cylinder, showing simple free diffusion to contrast the convective mass transfer sample induced by rotating a cylinder flow. We use two different liquid mediums, water and corn syrup, whose varying concentrations and densities will affect diffusion and the fluid flow. After adding 2 drops of food coloring, we measured the rate at which the mixture becomes homogeneous. We would expect to see the free diffusion samples to take much longer than their convective mass transfer counterparts. Looking from above, once the cylinder gets spinning, it takes a few minutes for it to reach steady state. Before this, there's little fluid flow happening towards the center of the cylinder. This simulation helps us estimate the amount of time it takes the cylinder to fully develop its flow. These two-dimensional COMSOL simulations show the transient or non-steady state comparison of free diffusion and convective mass transfer. As you can see by the relative times, free diffusion is much slower, measuring on the scale of days, while the convective simulation only took a few hundred seconds. The white flow lines show the direction of concentration movement. For this three-dimensional simulation, we used the diffusivity and properties of corn syrup and water. Much like the previous simulations, the free diffusion took a much longer time to reach the same homogeneity. Since we did not have all the precise characteristics of corn syrup, it is likely that this would not take 50 years to reach fully homogeneous mixture. Regardless, it serves as a good base of understanding the relative time difference between the two mechanisms. We decided to test our hypothesis using 2 different fluids with drastically different viscosities, corn syrup and water. For our first trial, we ran water undergoing just simple free diffusion, as well as with the addition of convection. Looking at the results, free diffusion took about 60 minutes to reach a somewhat homogeneous solution between the water and food coloring. With forced convection, after only about 4 minutes, a significant portion of the food coloring had been dispersed. With free diffusion, after 5 days, the corn syrup had only absorbed a slight amount of the food coloring. However, with forced convection, after about 40 minutes, a significant portion of the food coloring had been absorbed. Clearly, with the addition of forced convection, the dye is able to diffuse into the corn syrup in a shorter time. Additionally, the much longer times in both free diffusion and convection for trial 2 show the effects of using a liquid medium of much higher density and viscosity. In conclusion, stirring induces convective mass transfer, which drastically decreases the time of sugar dispersion. While both mechanisms will get you to your desired cold brew, using a spoon to speed up the process may save you hours, and even days in waiting. Ultimately, the choice is yours. Thank you, and have a great day.